So when we're differentiating, what we're doing is we're finding the gradient of a function. So when we say a function is differentiable, what that means is that we can find the gradient of a tangent. But we have looked at functions where that's not going to be possible. So what you need to look for is things like continuity, discontinuity, and things like that. So some examples of where you cannot differentiate a function. Looking at this first graph, what we've got here is the hyperbola. Hopefully we all remember that from the function topic. So a hyperbola has this issue of this asymptote down the center here. And you can't find a gradient if there's no function there. And so when a graph is discontinuous, it has a point of discontinuity, then you cannot differentiate at that point. And what you're going to find when you try and differentiate the equation is that there's something happening at that point that means that we cannot find a derivative, which makes sense because for a hyperbola, your basic equation is 1 over x, and when x is 0, you get 1 divided by 0, which is undefined. So I can't find the gradient of something that doesn't exist as far as we know. So you're looking for discontinuity, and that's the same sort of thing happening in this second example. Whatever this function is, there's this one point that it doesn't exist for. So this is what happens when you get things that have stuff like x over 2 on the bottom. We can't find a value at x equals 2 because there's that point of discontinuity again, because you would be dividing by 0. So you need to look for points like that, which means we can't differentiate at that point. So both of these graphs are discontinuous, and we cannot differentiate at that point. We can differentiate at the other points, but not at the points of discontinuity. Okay, now the other thing that you need in order to be able to differentiate is a smooth function. Because you're finding the gradient, what you're doing is finding the gradient of a tangent at the curve. But for this third example, there's this point here where we move from a parabola to a straight line. And where do you draw the tangent there? I mean, is it going to be the tangent for the parabola, or is it going to be the tangent for the straight line? Which way does it go? It's not smooth. And so if it's not smooth, then you can't differentiate there either. Okay, so discontinuity means that we cannot differentiate. If it's not smooth, that means we cannot differentiate. Now, if they give you the graph, this is easy. You just look for a point where there's an asymptote, where there's a hole in the graph, or where there's this bend or something like that that you can't differentiate. But we also have ones like this. So they're asking us, is this function, which is defined by two separate things here, we've got x squared minus 3 when x is greater than or equal to 0, and 2x minus 3 when x is less than 0. So the first thing we need to know is, well, is there a value at those points? Like, does it line up at that point x equals 0? Because if one of the functions gave us a value of 5 and another one gave us a value of 2 and there was this jump and no gap in between, we would have that discontinuity. So that's the first thing we need to check. So at x is equal to 0, we check the two functions. So x squared minus 3 is equal to 0 minus 3, which is negative 3. Okay, and then you check the second part of the function. 2x minus 3, well, that's going to be 2 zeros minus 3. So you can tell that the two parts of this graph line up. Okay, so we don't have that hole in the gap where we're missing something. So then what we need to do is say, well, what does it look like? So you only need a sketch. You don't need a proper graph at this stage. X squared minus 3, hopefully we're all aware, is a parabola. That's what the x squared tells us, and it's positive, so it's a happy face one. And we're drawing it to the point where x is 0. So at 0, this is equal to negative 3. We just worked that out. So we have this parabolic shape that crosses at negative 3. And then it changes to a straight line, 2x minus 3. So that means it curves up that way. That means it heads up that way because it's got a gradient of 2. Now, is that a smooth curve? Well, at the point x equals 0, it's not. So this is not differentiable. And that's all you need to know for exercise 8.2. Now, I do want you to check over each of them, but as you can see from those first few examples, a lot of them you're just going to be looking at them and going, yes, no, oh, it's that point there. I don't particularly mind if you don't even write down the answers, as long as you look at it and you make sure that you understand what's going on. Good luck, and I'll see you in class.